Hey, geometry, this is section 9.6. In section 9.5, we talked about tangent lines. So I'm going to review that really quick. A tangent line, if you have a circle, is a line that's only going to touch your circle at one place. Um, a secant line is a line that's going to, let's say there's the center of my circle right here. A secant line is a line that's going to touch your circle at two places. So it's kind of like a chord, but the line keeps going through the circle, and a lot of times it ends up making an angle with like a tangent line, which we're going to talk about here in just a little bit. So this is a secant line. This is a tangent line. We're going to talk about what this angle measure is and that type of thing. So secant lines just look like what's over here on the right side, where you have a line that's going through and hitting the circle at two spots. So secant line is a line that intersects the circle in exactly two places. All right. The first theorem that they have is 912, and they're talking about angle 1 right here. And they're saying that the measure of angle 1, which is made by these two secant lines intersecting with each other, if you would take AB, whatever the measure of AB was, and add that to DC, that would give you the measure of angle 1. So, or excuse me, and then divide that by 2, that would give you the measure of angle 1. So in my example, I have that, let's say this is a 120 degree arc right here. That arc is 120 degrees. Let's say this arc is 140 degrees. So to find out the measure of angle 1, okay, because angle 1 is not necessarily in the center of the circle, if this point right here was exactly dead in the center, then this angle would be the same measure as this arc, but it's not dead in the center of the circle. Those two are just crossing each other at a random place. Angle 1 is made by 120 degrees plus 140 and then divided by 2. So you add those two together and divide by 2. 120 plus 140 is 260. 260 divided by 2 is 130. So this guy would be right here 130 degrees, all right? And the reason for that is because these two secant lines do not cross dead in the center. If this was the center, then this arc would be 120 degrees, but it's not. So that's why you have to add these two together. It's like taking the average of the two, adding them together and dividing by 2, all right? Let me have you, I'll just go through all of these theorems, and then we'll write down the theorems on the last steps. So at the very end, we'll write those down. So example 1, you have this angle x, and here's a better picture of what it looks like where the secant lines are not crossing into the center. Okay, so this point right here, V, is obviously not the center of the circle. If it was, then angle x would be 130 degrees, but it's not. So what we have to do is we have to add 84 and 130 together and average them, add them together and divide by 2. So 84 plus 130 divided by 2. 84 plus 130 is 214 divided by 2 is 107. So this is 214 divided by 2, 107 degrees. So 107 is the measure here, but then 107 is also the measure over here because those are vertical angles that run across from each other. So angle x is 107, all right? Now this angle right here is a little bit different. He is not across from the 45 and 75, okay? So what we're going to, or excuse me, 143 and 75. To find this angle on this side, we would average the 143 and 75 together. 143 plus 75 divided by 2. 143 plus 75 divided by 2. So that is 218 divided by 2, or 109. So this angle right here is 109 degrees, and the same thing over here. This is 109 right here also. Okay. So those two right across from each other are 109. Now they want this pink angle right in here, that angle x. And you can kind of look at this straight line here and notice that those two have to add up to be 180 degrees. So 180 minus 109 has to be, I think, 71. So angle x is actually going to be 71, all right? If angle x was here, like straight in line with the 143 and 75, then x would be 109. But it's over here, so we have to subtract that from 20. So that's the additional step that we have to do from part A to part B, okay? Now part C is a little bit more involved yet. in that normally we take 97 and we add it to this value and divide by 2 to get this one. So I'm just going to write that out. 97 plus x divided by 2 normally will give us this value in here, which they say is 110. So I'm just going to write all of that out, and then we're going to solve for x. We're going to work backwards. All right. So just to review that, 97 plus x divided by 2 will give you this inner one here. All right. Then to solve for x, I'm going to multiply by 2 to get rid of that 2 on that side. 97 plus x is then equal to 220. Okay. And then to get x by itself, I just subtract 97. And 220 minus 97 is 123. So x is 123 degrees. That's what P is up here. 123 degrees, all right? If you want to check that, adding 97 to 123 and dividing that by 2, you should get 110. But working backwards, that's how we did that there, all right? So kind of just remember that you're averaging these two. You're setting those two arcs, adding them together, dividing by 2 to equal that middle angle there, okay? All right, our next theorem says this. What we have is we have a secant line, which is touching your circle at 2 places, once here and once here, and it's intersecting with a tangent line. So this tangent line is making a T with the circle. And so our secant line is intersecting our tangent line at that point where he is tangent. That's the point of tangent C right there. And they want us to find the measure of angle 1 or the measure of angle 2, all right? So the measure of angle 1 is kind of separated by this chunk here, this arc that's AB on this side, okay? And what they're saying here is when you have a secant line intersecting a tangent line, it kind of splits it into like a little half moon here. Angle 1 is going to be half of what this arc measure is. So let's say this arc is 160 degrees. Angle 1 is just half of that, so this would be 80 here. Okay? If this arc is 160 right here, then this guy all the way around here has to be 200 because they have to add up to be 360. 160 plus 200 is 360. So this arc right here is half of 200 or 100. Well, now look, I can check myself because 80 right here and 100 right here add up to be 180, which is that straight line. Okay. So when your angle is across from that arc, it's just going to be half. And we kind of had a theorem that was kind of like that before, where I have this angle is half of what this arc is. Kind of the same thing here. Okay, so secant lines and tangent lines are intersecting with each other. I'm just going to mark this one is my tangent line just for practice. Tangent line, this one is my secant line. Secant line is touching at 2 places. My tangent line is touching at only 1 place, okay? And they want us to find the measure of QPR. QPR is this angle right here. The arc measure is 148, and this angle measure is half of that, so this has to be 74 degrees, okay? That's all they wanted for that one, all right? DEF is the next one. Let's talk about this one for just a second. Let's label these. This angle, or this line, if I would continue it on out, this is going to be my tangent line because he's only touching at 1 place. This one's going to be my secant line because he's touching at 2 places. Okay, so tangent line, secant line. They want to know the measure of arc DEF. DEF, all the way around over here. Okay, now there's a couple different ways that you can do this. You can say that 64 is this angle right here, and it lives on a straight line. So if this is 64, I subtract that from 180. 180 minus 64, and that gives me 116. So this angle right here is 116. Okay, this is a teeny tiny angle in there. Then that means this arc is double that. So this arc is 232, I believe. If I double 116, 232 is what this arc would be. Now, I could also do that another way. 64, if I double that, that's 128. And then I subtract that from 360 to get 232. So that's another way of doing it. If I go around in the circle this direction versus going this direction. Does that make sense? Okay. So there's A and B. Those arcs have to be double the measure of what the angle is. Okay. Moving on to the back side. Again, we'll write these theorems down all at the very end. So this last one says, this last theorem says that if I have a secant line that is attached to another secant line, which is making this angle outside of the circle. Okay, I'm going to flip back to the front side and we'll show you why that's different. Over here I had two secant lines that were intersecting and making a cross inside of the circle. Those two, you added them together and divided by 2. Okay, in this one, when it's outside of the circle, I'm going to take this arc and I'm going to subtract the measure of this arc and divide that by 2. So it's 1/2 of the large arc minus the small arc. Okay, and that's true whether you have this scenario happening or something like this happening or something like this happening. All of them are going to be the same. You're going to take the large arc, you're going to subtract the small arc, and divide by 2 to get this angle. Large arc minus small arc, divide by 2 to get this angle. Okay, you subtract when they're connecting, when your vertex is outside of the circle. On the other one, the vertex was inside of the circle. They were making kind of a cross. All right. So down here, find the measure of angle L. Okay, now angle L, it would be nice to think that angle L is 102 degrees, but it is not. 102 is representing this little arc right here. Okay, so if that's 102, let's think what this would be all the way around here, what this large arc is. Okay, if that's 102, I can take 360, which is a whole circle, and I subtract 102 to get, what, 258, I think is what that is. 258 is that larger arc, that major arc. This is the minor arc of 102, right? And since my vertex, my L, is outside of the circle, I subtract those and divide by 2. So the formula is 258 minus 102 divided by 2. 258 minus 102 divided by 2. This is 156 divided by 2, which is 78 degrees. So this little L right here is 78 degrees. Okay? When the vertex is outside of the circle, you subtract and divide by 2. Right? Same thing here, but this one's a little tougher. We are trying to find the measure of arc CD instead. Okay? Now, I know that this guy right here is 95. And we could just subtract from 360, but that will give me this whole length here. I want just this guy. If I subtract from 360, it'll give me all the rest of this. I don't want this part. I just want this part. Okay? So let's designate CD, what we're trying to find, as X. Okay? 56 is the measure of this angle. So what I would do is I would take X, I would subtract 95, the large arc minus the small arc, and divide that by 2, and that would be equal to 56 is the angle. All right? This large arc minus the small arc divided by 2 is 56. Okay? Now I do, just like I did in part C on the front side, I reverse the order of this. So I want to get rid of that 2 first. Opposite of dividing by 2 is multiplying by 2. I'm going to multiply by 2. X minus 95 equals 112 is 56 times 2. 112. Right? Then I'm going to add 95 to get the 95 to the other side. X equals, and that is 207, I believe. Yes, 207. So this degree right here, this arc right here is 207. Okay? So that one we kind of had to do backwards. So just remember, you're subtracting, dividing by 2 to get the measure of this angle when he's outside. Right? Going back to the front side, when the angles are intersecting on the inside of the circle, you add them together and divide by 2. Adding together, divide by 2. Subtracting, divide by 2. Okay? All right. So this last question is a story problem. The diagram shows the path of light rays as it hits a drop of water. The ray is bent or refracted at points A, B, and C. So it's, let's see, we have lines going here, I think. A, B, C. It says if the measure of AC, arc AC is 128, and the measure of XBY, this arc right here is 84. What is the measure of angle D? Okay, so we have this circle, and those light rays are going through there. This is 128. That's the large arc minus the small arc. gives you the angle. Okay, so 128, scoot this over, 128 minus 84 divided by 2 equals angle D, whatever angle D is. Right? Since D is outside of the circle, we subtract and divide by 2. Right? So 128 minus 84 divided by 2. This is 44 divided by 2, which is 22. So this angle right here is 22 degrees. Okay? Outside of the circle, you subtract and divide by 2. Right? So this key concept down here is just summarizing the 3 theorems that we had. So if you have your secant line that is on the circle, or your angle that is on the circle, this arc right here will be double what the angle is, or the angle will be half of that. So if this is 100 degrees, this will be 50 degrees. Okay. Same thing over here. If you have this angle here and this arc right here, the angle is half of what the arc is. So 120 degrees. This guy is 60. Right. If they intersect inside of the circle, you add the angles together and divide by 2. So let's say 70 and 50 degrees added together. 70 plus 50 is 120 divided by 2. This guy would be 60 in here. It's like you're taking the average of the two, all right? And then any one of these is where your vertex is on the outside of the circle. Outside, outside, outside. You are subtracting the large arc minus the small arc. The large arc minus the small arc. The large arc minus the small arc. Dividing by 2, and then that gives you the angle. So let me do, let's say this is 210. Let's say this is 150. So you would do 210 minus 150 divided by 2. 210 minus 150 is 160 divided by 2 is 80. 80 degrees is the measure of that angle. Okay, so there you go. Adding together, divide by 2. Subtracting, divide by 2. This one you're just dividing by 2. So we're taking half. All right. So here are the theorems that I have. I'm going to zoom out because I've got a lot of stuff. And I just kind of drew pictures. So theorem 912, 913, 914. I drew a picture here. This is A, B, C, and D. And I said AB is 120 and CD is 140. That goes to there. All right. When you have the arcs intersecting inside of the circle, you add those two together and divide by 2. So 120 plus 140 divided by 2 is 130. Angle 1 is 130. Right? If I have angle 1 here and I have arc AB is 300, I just take half of that to figure out what angle 1 is. So 300 divided by 2 is 150. That's what angle 1 will be. And then when they're intersecting outside of the circle, I subtract the arcs. So this is 140, this is 80. 140 minus 80 divided by 2 is 30. Okay? If you need to pause this, go ahead and do so. And you can finish writing those theorems in there, but that is what section 9.6 is.